This is Math 3, Unit 9, Section 8, Notes, Applications of Logarithms, which means we're doing word problems with logarithmic functions. So, straight away, we're given a description of what this first formula means. So we're going to break it up by highlighting each piece. So the amount that an investment is worth is called A, or we use the letter A to represent that, is based off of several different things. The first being the principal, P. So the principal is how much you invest, so how much you start with. So whatever's invested is called P. The interest rate, and we know that rates, or at least interest rates, are represented as percentages. So we're looking for a percent for that one. The number of times per year the investment is compounded. So how many times a year does this interest rate apply? That we use the letter N. N. And T, which is the time that has passed. So time in years. Okay, so we're going to use this formula to solve all three parts of this first question. So if a person invests $700, that means that's how much you start with, not the amount that it's worth in the end, but how much you invest, which is called the principal. In an account that earns a yearly interest rate of 4%, so that's our rate, and we're going to use the decimal version of that percentage, so just divide that by 100 to get your rate. And then other unknowns are going to be given through A, B, and C, so some things might change and some things might stay the same. So let's move on to part A. How much would this investment be worth in 10 years, which would be our time, if it is compounded once per year? So once per year means our N is 1. And we're going to go ahead and set up that equation. So we have A equals P, which is 700, parentheses, 1 plus R over N, which would be 0.04 over 1, raised to the N times T, which would be 1 times 10. All right, I'm going to write a simplified version of that equation. So simplifying the right-hand side, the 700 is going to stay the same. 0.04. Remember, you need, inside the parentheses, you need to divide and then add, order of operations, division first, then addition. So 0.04 divided by 1 is 0.04, and 0.04 plus 1 is 1.04. If you need to use a calculator, you can do that. And then 1 times 10 is 10. Now, the rest of this can be plugged in on the calculator. So we're going to do 700 times 1.04 to the 10th power. You can see that. 700 times 1.04 to the 10th power. As long as you can type it all in, then you should have an accurate answer, and you just push enter. You don't want to round until you get to the very end, and we're talking about money, so we want 2 decimal places to represent our change. So $1,036.17. Oops, $1,036.17. Okay, we're going to do the same thing, but this time the only thing that changes is how many times per year we compound. So quarterly means 4 times per year, so my n changes to 4, but my t is still equal to 10. All right, so the only thing that changes is the 4, so the 700 stays the same. 1 plus 0.04 over 4 to the 4 times 10. So I changed the n both in the denominator here and in the exponent. Inside the parentheses, we're going to do 0.04 divided by 4, which is 0.01. 0.01 plus 1 is 1.01. And then 4 times 10 is 40, so our exponent is 40. We're going to type all of that into the calculator. 700 times 1.01 raised to the 40th power. And that gives us $1,042.20, which means if it's compounded more per year, then we earn more money, basically. So the next one is going to be compounded monthly. How many months are in a year? 12. So our n has changed to 12. And this next answer, because it's compounded more, should be more than the previous 2 answers. So keep that in mind when you're plugging into your calculator. Some people make rounding errors on this problem, on this part C. So let's take a look at what we got. All right, so we still have A equals 700 times 1 plus 0.04, this time over 12, raised to the 12 times 10. Here's where things get tricky. 0.04 divided by 12, you probably need to do it on your calculator, or you can get a common, you can multiply each of them by 100 and then reduce and get a fraction, but we get a decimal that's repeating. When you have a decimal like this that's repeating, you want to use all of those repeating 3's, otherwise you make less money, because 0.003 is less than 0.00333333. So you want to make sure you have all, and you can't round it up, because then that means that you're going to predict that you will make more money than you'll actually make. So you want to use this exact number. So what we're going to do here is do the same process of what we would do for this center part on the calculator, and then we're going to follow our order of operations, but we're going to do it all manually. So we did 0.04 divided by 12. That gave us 0.003 repeating. This repeating part is very important, so I'm going to write it down. If I add a 1 to that, I'm going to show that on the calculator, plus 1. Then that gives me 1.03 repeating. So I still have my 700 out in front. 12 times 10, we can do that in our head. That's 120. Okay, now we need to follow the order of operations, but you need to use what's in your calculator already, so that you have the correct answer. So what's my order of operations now? Do I multiply it by 700 first, or do I raise to the 120th power first? Hopefully you said exponents before multiplication. So we're going to raise this to the 120th power. And after that, we don't need to write that number down, but after that, it should be multiplied by 700, and that'll give us our final answer of $1,043.58. Okay, now, we did not use any logarithms on this problem. Logarithms are used in order to determine what exponents are. So let's take a look at our exponents in this problem. One of our exponents is n, and the other exponent is t. We were given n and t when we were given how many times per year it was compounded and how many years went by. If you don't know one of these, or you're trying to solve for one of these answers, we have to use logarithms in order to get the exponent down from the exponent position and be able to solve. So if you're solving for n or t, then you're going to use logarithms. Let's take a look at this next problem. If we need to solve for r or t, which is the rate or time, then we need to use logarithms. So you'll notice that before I even get to all the information I have for the question, if I go down to part B, it says, how much would this investment be worth after 15 years? Okay, well, I'm given principal, which is money, I'm given a rate, and I'm given time. So if I'm given a rate and time, I'm not going to need to use logarithms because I'm given both a rate and a time, which means I just plug my answers in and then solve. Determine the time it will take for the investment to reach 700. Determine the time. Time is in the exponent. So on this problem, I'm going to have to use logarithms. So we'll get there in a second, but let's answer the other parts of the question first. Okay. An amount A, an investment is compounded, the amount that an investment is compounded continuously is based off of the principal, the rate, and the time. So we only have principal, rate, and time on this new equation. And that's because of this statement right here, compounded continuously. If it's compounded once per year, or 4 times per year, or 12 times per year, you have to use the equation that has n in it. But here, it's compounded constantly or continuously, so you don't need n. So we have this new formula, A equals P times E to the RT. All right, 500, a person invests 500. An investment is called the principal, so that's P. The rate is 2.5%. We want to change that to a decimal, so we divide by 100, and that gives us 0.25. I'm sorry, 0.025. And after part A, it says write an equation for the amount this investment will be worth after T years. So I don't know time yet, so that's just T. So I don't know A, I know P, so let's plug that in. E is a constant, so that stays the same. R is 0.025, and if I multiply R times T, that's 0.025 T. There's your equation. How much would this investment be worth after 15 years? So the only thing that changes from the equation above is we're going to multiply. We're going to plug in the 15 for T. So we multiply those exponents together. All right. That's going to give me 500, so A equals 500. E to the 0.025 times 15 is 0.375 exactly. We don't want to round on these, remember, until the very end. So now we're going to do 500, and then you should have an E button on your calculator. Usually it's around the logarithm buttons because it has to do with the same thing. I right here have an e to the x, so I'm going to go ahead and use that. e to the 0.375, which gives me $721, and it's 0.495, so that's 50 cents. We're going to use the same equation from part A for this next problem because we still have $500 invested, and we still have the same interest rate compounded continuously. And then now we have a new dollar amount. It says determine the time it will take for the investment to reach $700. So this is our A. That's how much it's worth after time has passed. So you'll notice in part B, it took 15 years to get to $727, which means part C should be less than 15 years because this is growing. All right. Let's go ahead and plug in 700 for A. Now, the only unknown in this problem is T. E is a very specific number that you can find on your calculator. You can even plug it in. Just do e to the first. 2.718281828, etc. But we just use e whenever we're calculating. Now, I'm going to isolate the base and the exponent. Okay, so my base is e, and it's raised to an exponent. So this 500 we're going to get rid of by dividing it to the other side. All right, so that gives me 700 divided by 500 is 1.4. The 500 reduced, and you're left with e to the 0.025t. So get that base and the exponent by itself before you move on. Now, if we want to get something out of the exponent position, we need to change forms. So you're going to change to log form or natural log form, ln. Remember, these are L's, so log form or ln form at this point. Now, ln is just log base e. So if I write log e, that's the same as ln. Just a side note there for you to remember from other sections. So since my base is e, I'm going to take the natural log in order to change forms. And remember, when we're changing to log form, we take the natural log, base e, of your answer, 1.4, equals your exponent. And in this case, my exponent is 0.025t. Log, base, answer equals exponent. And that's from very early on in section 2 or 3. All right, now this part right here, log base e, or the natural log. We don't have to write the e when it's a natural log, but there is a button on your calculator that you're going to solve this. But let's isolate t before we do that. So getting t by itself, divide by 0.025 on each side. Okay, so all of this reduces and we're left with t. So the natural log of 1.4 over 0.025, and we're going to plug that in on the calculator. So ln 1.4, close parentheses. You can push enter first and then divide by 0.025, but you don't have to. So we did the natural log of 1.4 and then divided that by 0.025. And we get 13 we're going to round to the nearest tenth of a year. Make sure you follow instructions. So 13.5. So our time is approximately 13.5 years. Okay, flip to the other side. An investment of $300 is made at a 3% interest rate, compounded quarterly. So compounded quarterly means we're using the first equation from the other page. So that equation, I'm going to write at the top here. A equals P times 1 plus R over N to the N times 10. Now remember, let's make a note at the bottom of the page here. If you have compounded continuously, you're going to use A equals P times E to the RT. A lot of people say PERT. That's for compounded continuously. That's probably the one we use the most. That's called simple interest. This is called compound interest. So if you're wondering how to make money and putting your savings into something and want to know whether it's going to be better to make an investment that is compounded or is continuously or over a certain amount of time, you gotta calculate it out. All right. Write an equation for the amount of this investment would be worth after t years. So we don't know t. The investment is our principal. The rate, 3%, is written as 0.03, or you can just write 0.03. Compounded quarterly means 4 times a year. N equals 4. So A equals $350 times 1 plus 0.03 over 4 to the 4 times t, which is 4t. And you can just leave it like that. Or you can also do 0.03 divided by 4, and that would give you 0.0075. So another option is this right here. Okay. Either way is correct. All right. How much would this investment be worth after 20 years? Now, if I did 0.03 divided by 4 and got 0.0075 and then added the 1, I probably want to use this more simplified equation in order to do my next calculation. Oops, I already added the 1. And then 4 times 20, which would be 80. And you can type all of that into your calculator. $636.32. And last, determine the time it will take for the investment to double. If the investment doubles, remember, we start off with 350. If we're going to double that, that will get us to 700. Okay, so that's how much we want to end with in order for our investment to double. All right, so if I'm using this equation, let's do the right-hand side, this equation right here. The part that I end with is A. That's how much money I end with. So 700 equals 350 times 1.0075 to the 4t. And it says to determine the time, so we don't know what t is yet. So don't put in the 20 for t. This is a different part of the problem. But all of the other pieces, the interest rate, the compounded quarterly, that all comes from the entire problem as a whole. So any of those that aren't part specific, you can use for every piece. All right. So remember, we're trying to figure out an unknown exponent. And if you have an unknown exponent, that's when we use logarithms. That's why they're important. Because remember in section 1 we called it the what power function. So if we don't know what the power is, we need to use logarithms to figure it out. But we're going to isolate the base raised to the exponent first. So get rid of the 350, which means we divide it to the other side. 700 divided by 350 is 2. All right, notice this is a 2 because that's how long we're trying to figure out how long it takes to double. If we wanted to know how long it took to triple, this would be a 3. To quadruple, it would be a 4. Once you have your base raised to the exponent isolated, then you change forms. All right, our base is 1.0075. So if I'm going to change to log form, I write log base 1.0075 of my answer equals my exponent. So we're solving for the exponent. All right, let's isolate t, which means I divide 4 to each side. Okay, now here's the tricky part. Some of you have fancy calculators that let you put in different logarithm bases. Not all of us have that. So what we need to do is calculate this numerator part first. So if I'm calculating 1.0075 log of 1.0075 log base 1.0075 of 2, we're going to do our change of base theorem. The change of base theorem we did in another section. That means I do log of 2 over log of 1.0075. Okay, let's go ahead and calculate what that would be. Log of 2 divided by log of 1.0075. All right, once I get that value, I can write the approximation down, but I'm going to actually use that keeps going. I'm going to actually use the number that's on my calculator. So, since I figured out what this value is on my calculator, I'm going to divide that by 4 to get t. So this number, you see it, divided by 4. And then we're going to round to the nearest tenth of a year, so 23.2. So t equals 23.2 years. Alright. Sorry, this is old. Don't worry about that. Your other information is on Google Classroom.